As I mentioned in the first presentation, sometimes, unfortunately, good scientists turn to pseudoscience and waste their talents proposing nonsense theories. One such loss was Sir Fred Hoyle, the brilliant astrophysicist who founded the institution in Cambridge where I earned my PhD. Hoyle is often mentioned by creationists because he converted to belief in a god late in his life, and after that point seemed to turn away from mainstream science and towards a number of strange beliefs, including, as creationists love to point out, disbelief in evolution. Hoyle's earlier work was based around how heavy chemical elements are formed in the interiors of massive stars, but perhaps his most famous legacy to science is the term Big Bang, which he coined as a joke, attempting to poke fun at the theory. Of course, the term stuck. It should be stressed at this time that Hoyle was definitely not a young Earth creationist at any point in his life. If the people who are so fond of quoting his later pronouncements on evolution instead were to read his work on astrophysics, they would realise that he accepted the age of the universe in the billions of years, and would have regarded the young Earth theory as nonsense. In fact, more than that, Hoyle believed in a model of the universe called the steady-state theory. He wasn't convinced by models for the Big Bang, and he believed that the universe had been, as it currently is, forever. It never had a beginning. He believed that matter was being continually created at its centre by some physical process and spewed outwards, accounting for the apparent expansion. This theory has long since been disproven, but the point remains that creationists selectively quote Hoyle, pointing out that he rejected natural selection as a driver for evolution, but he was in complete opposition to pretty much everything else that they believe. Hoyle believed that life on Earth was literally created, perhaps billions of years ago, by a creator. He supported the idea, known as panspermia, that life had originated in space and was brought to Earth on comets. He rejected the theory of chemical evolution and instead believed that evolution was driven by the arrival of new genetic material in the form of viruses from space. Hoyle thought that the idea of natural selection was extraordinarily unlikely and considered himself to be a proponent of what we would now call intelligent design, the theory that life is too complex to have evolved and that it must have had a designer of some kind, meaning God. The misunderstanding Hoyle had, which is so common some refer to it as Hoyle's fallacy, was to misunderstand the mechanism of evolution and to assume that it is a random process. Hoyle famously likened the assembly of the building blocks of life as similar to a tornado passing through a junkyard and assembling a complete Boeing 747 aircraft. Genetic mutations and crossover might be largely random, but that's not the point. Natural selection is a highly non-random process, and Hoyle never seemed to understand this. He also completely misunderstood the way that simple chemicals were first assembled, not all in one go by a spectacular act of chance, but instead in incremental steps via many intermediate stages. Unfortunately, with certain strong-willed people, once they get an emotional attachment to, or sometimes against, a theory, especially when they stake their pride and reputation on it, it becomes difficult, if not impossible, to dissuade them from their error. I mention Hoyle in this presentation on cosmology merely because it's where he belongs. Hoyle was a true giant of astronomy, and it seems a great shame that he is often remembered and quoted for the things he got wrong or misunderstood, often in sciences at which he was not an expert. But he's a great example of how science works. Just because he was a highly respected scientist, that doesn't mean that his ideas were all correct. Einstein himself said that he thought 99% of his ideas were nonsense, but the 1% remaining, that's why we call him a genius. Hoyle's ideas were rejected because they disagreed with the evidence. Scientific theories can be proposed by a highly decorated professor or by a 10-year-old child. It doesn't matter. What matters is whether or not they stand up to the scientific process of evidence gathering and analysis. Fred Hoyle was turned against a truly scientific view of the universe and towards the concept of intelligent design, at least partly by the problem of the fine-tuning argument. I must admit it's one of the very few arguments where I actually understand why it could lead someone to doubt a wholly natural universe. Not that I feel that way myself, but it is a very puzzling conundrum, and there is no good resolution to it yet. It's fairly unlikely that you'll encounter this argument, but with the more sophisticated intelligent design proponents, it is becoming rather more common. It's worth pointing out that the creationist alternatives to the common scientific viewpoint here are much, much worse. They barely explain the fine-tuning problem, and they introduce many other, far worse problems for which no solution could possibly be envisaged. So although science doesn't do a convincing job of solving this issue yet, and it will eventually, that doesn't mean that there are any better alternatives and that you should just throw out science and accept something without any proof whatsoever. So what is this enigmatic problem? Well, it's all to do with fundamental physical constants. You'll definitely have heard of some of these, like the speed of light, for example. The speed of light measured in a vacuum is exactly the same everywhere in the universe. It's based on laws that are absolutely central to our understanding of physics. It's a constant, meaning that it does not vary with time, space, or surroundings. We measure it here on Earth to be around 300,000 kilometers per second, and we would measure the same value everywhere else in the universe. And the speed of light is one of about 25 fundamental constants in physics. Others are, for example, the ratio of the mass of a proton to an electron, or the constant in Newton's famous law of gravitation that tells us exactly how much force is felt by two objects, given their masses and separation. You probably won't have heard of many of the others, like the fine structure constant or the strong coupling constant, which is nowhere near as erotic as it sounds. The thing is that these constants are all very important in how the universe works. If they differed by even a tiny amount in most cases, then the universe would not have formed as it did. For example, it might never have coalesced into galaxies and stars, or maybe the heat in collapsing gas clouds would never have been hot enough to kickstart nuclear fusion. Or maybe fusion couldn't have created heavy elements and hence no life. Or maybe the first black holes would have run out of control and swallowed all matter in an instant. So the fact that the universal constants have such precise values, seemingly exactly the right values to allow a universe capable of supporting life, is something of a puzzle. But it's not a puzzle without explanations, and let's remind ourselves that the creationist explanation of God did it really isn't satisfactory, because we still haven't explained where this God came from and how he was able to exist without some other parameters being equally fine-tuned. When it comes to explaining problems like this, I think most cosmologists would admit that they're more or less guessing based on intelligent lines of evidence, extrapolating from known theories perhaps, but guessing nonetheless. One suggestion is simply that the fact the universe is such that it can harbour life is an obvious conclusion because we're here to observe it. After all, if it weren't capable of harbouring life, then there would be no life around to ask why that was the case. Maybe there has been a countless number of universes with different parameters, or maybe our own universe has sprung into existence and collapsed many, many times, each time with different fundamental parameters, until one version happened to form that had conditions just right for life. That's a version of the anthropic argument, and it's not particularly satisfying, but hard to disagree with. And most scientific theories come from this kind of direction, talking about ideas such as parallel universes. I think this is a good opportunity where it's okay to say, we just don't know, and move on. Remind yourself that no superior alternative is presented by your opposition, admit it's something we're working on, and leave it there. I talked about redshift earlier when I was discussing the evidence for the expanding universe and the Big Bang. Redshift, if you remember, is the fact that when we look at objects moving away from us at very high speed, they appear redder. The faster an object is moving, the redder it appears to be. This isn't because the object itself is redder, it's just because of its apparent motion relative to us. This redshift gives us a good measure of the object's velocity away from us, and because we understand the mechanics of the expanding universe, and because its expansion speed varies in a known way with distance, the redshift of a distant galaxy tells us how far away it is. This isn't true of nearby objects like the galaxies in the local group, because their redshift is tiny and their own random velocities towards each other overwhelm the natural drift caused by the expanding universe. But as we get further and further away, the contribution from peculiar local galaxy motion becomes negligible compared to the expanding universe, and redshift becomes an extremely good measure of distance. However, creationists occasionally try to quote some rogue studies which contradict this theory. After all, if redshift is not reliable, then neither is the age of the universe. I won't go into any detail on these papers. They are genuine papers, quoted by Kent Hovind amongst others, as arguments that redshift is unreliable. The papers by Arp and Burbidge in the late 60s deal with a statistical effect, and yes, creationists quote 40-year-old research. Way to go. The paper claims that quasars, that is, a certain class of very bright and distant cosmological objects, seem statistically much more common close to nearby galaxies. Now, this shouldn't be the case if they're very far away, like cosmologists claim. Well, it turns out that this was just a false lead. Later studies measured far more of these objects, and the truth is that they're not associated with local galaxies at all, and are distributed evenly across the sky. So creationists are quoting a very old, incorrect and misleading piece of research to try to get their point across. And you better get used to that. The second paper is a bit different. This is a much more recent study from 2005, which shows a quasar, which is measured from its redshift as being very distant, but it appears to be in a much closer galaxy. The solution to this puzzle isn't known yet, but it's not much to worry about. it could be a coincidental alignment, or maybe just that the quasar was ejected from its host galaxy at very high speed. There's a number of other possible explanations. The main point here is that one tiny anomaly doesn't pour doubt on a theory which is supported very well by thousands of other observations. Remember, we have lots and lots of observations of quasars with their host galaxies where the two have identical redshifts, and those redshifts can be very large indeed. So that's a couple of specific examples. There's two really huge problems with this whole approach from the creationists, however. Firstly, even if redshift is unreliable, which is very unlikely indeed, the story from cosmology is still that the universe is overwhelmingly old, way more than 10,000 years. Once you've acknowledged that redshift is even a measurable phenomenon, then you've pretty much admitted that the universe is at least hundreds of millions of years old, which scuppers the young Earth claims entirely. Secondly, and perhaps more damning, is that the creationists have shot themselves in the foot by quoting real scientific papers which, when they were published, massively disagreed with the status quo. Creationists claim this never happens and that scientists merely stifle dissent all the time, and that's why evolution is still around. They claim that nobody dares say anything against the prevailing theories and it's impossible to get published when they do. Well, they just disproved that pretty comprehensively themselves. Dissenting papers do get published. Of course, they're quite often wrong, so the forge of scientific debate, peer review and open discussion reveal the mistakes in the end. Finally, let's look at one last idea that has been suggested to explain away the apparently old age of the universe, that of a varying speed of light. Because our understanding of the universe is based on the assumption that the speed of light is a constant, then perhaps the universe might appear old if the speed of light were very much higher in the extremely recent past. If we see an object that looks to be 1,000,000 light years away, but if the speed of light used to be much faster than it is today, then that light could have reached us, say, within the 10,000 years that creationists claim. Of course, there's no reason why this would be the case, and no model for how it could be the case, and there are many ways we can study the universe which gives us extremely high confidence that it wasn't the case. For example, in 1987, astronomers were given the gift of a nearby supernova to study, named 1987A. It exploded in the nearby satellite galaxy known as the Large Magellanic Cloud. This allowed us to make direct measurements of physical processes happening in that explosion, which meant we could measure the speed of light as it was when the explosion happened. And the explosion was 200,000 light years away, so therefore it happened 200,000 years ago. It turns out that no variability in the speed of light was detected whatsoever. There are other ways we can prove that the speed of light hasn't changed in the recent past, including looking at pulsars. These are rapidly rotating objects that appear to pulse at an uncannily accurate rate. We understand the physics going on in these objects, which are actually rapidly rotating neutron stars. So we understand the slowdown rate and can measure it with extraordinarily high accuracy. If the speed of light used to be much faster, then we would see the pulsar appear to speed up over time as the speed of light dropped, and hence the successive pulses of radio waves got closer together. Of course, we don't see that at all. Measurements of the speed of light may have changed as our apparatus got more and more accurate, but that's not evidence for a changing speed of light. The varying speed of light theory as a way to explain away an apparently large universe is a theory without any evidence, without any model to explain it, and hence without any plausibility. Let's make a clear distinction here between the creationist arguments and the varying speed of light theories proposed by sensible cosmologists like Wang Huang. These are actually quite interesting and worth studying. They don't have any observational backing, of course, and they only refer to the first 10 to the minus 43 seconds of the universe. That is to say, the first 1/10 millionth of the age of the universe. So I don't think we need to worry about the effect that would have on our estimates for the universe's actual age. Thanks for listening to this talk. As ever, there's loads more information on my website, frame.net, where you can also find a transcript of this talk and all the following ones, and you can keep up to date with my blog as well as learning about some of my other work. See you next time.